continuing with day 14. We just solved day 13, part 2. Let's go to day 14. As for simply short recap, we're using for these challenges either ChatGPT or GPT-4, and also we use some of the APIs from OpenAI, or we are using also Bing for searching for some component of programs. We are solving the challenges using Go, and we are structuring our problems. Each day have its two folders. For example, day 13 have part 1 and part 2. They're separate folders. They're with separate copied files, etc. Everything is self-contained. And if we look at some of these examples, we have our main program that we make it runnable from here. We are reading the input from a file. We have test file, and we have also our prompting of the prompts that we gave, including the task, and having the answer from the either of our tools that we're asking, in this example GPT-4. And the main idea behind is that we want to simply be able to compare older and newer version eventually in the future. Let's do our usual thing. We simply copy the previous day for the new one. Here I want to paste day 13 and to call it day 14. As I said previously in one of my previous videos, when I attempt Advent of Code 2022, I solved it up to day 13, and I also did 2020, and I did it up to day 10 inclusive, and already I'm start getting to the limit of my abilities without using helping tools. In our case, the helping tools are GPT-4, Copilot, of course, as well, using Bing, and eventually making some calls to the OpenAI API for testing purposes. However, the other important part is that we need to spend more and more time of analyzing the problem, because usually, as we saw in day 13, there was a small problem, but we need to correct the programs and so on. And as I mentioned multiple times previously, I'm not professional Go developer. However, for the 2022 and 2020 Advent of Code, both times I was solving them in Go, and I'm familiar with the Go syntax. I have written some programs, some web servers, and in general I'm able to correct mistakes. I know the syntax and I know all the structure. It's not like we're trying to do something with language like Haskell, for example, although I know some Haskell, but if I haven't an idea of Haskell and I'm trying to solve the problems, there might be some shortcoming that it's actually very minor thing, but because of my absolute lack of knowledge I couldn't correct it and so on. In God the situation it's not like that, so to say I have no excuses if something doesn't work. It's either me not understanding the requirement well or it's something confusing in general, but not like a problem with the program on itself. Okay, let me delete this part. We have this. Okay, so far so good. We were using all of this. 1 second, I think that I git check out. Let me simply check out my file because I think I correct the wrong file. We were giving a context to GPT-4. You're a prominent competitive programmer. You have been invited in to participate in a programming competition and you're given a task to solve. And the instructions are write a Go program that solves the task and read the input from and how the file is called, etc. And here is the task. What we do with the task, we usually copy this, but yeah, depending of, I think this time because we'll start getting to problems that are getting more and more complicated, it's good to spend a couple of minutes of analyzing the task. Firstly, giving some rough idea what we would expect solution to be. We're the incredible pressure at the depth are starting to put strain on your submarine. Simply for a context, Advent of Code 2021 is a journey with a submarine. We are in the ocean bottom. We are hiding in a cave. We were escaping some creature that attack us, and we were navigating in the cave in some of the previous challenges. And at the moment there is a pressure for our submarine because of the depth. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine. We need to reinforce our submarine, and the nearby volcanically active cave should even have the necessary input element in sufficient quantities. That was our previous challenge, was to figure it out to enable a system that was going to give us to measure the temperature of the caves that have these volcanoes. And now the submarine manual contains instruction for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules. Your puzzle input. Okay, and our puzzle input is we're having a polymer template. I think that will be NNCB, and we're in a list of pair of insertion rules. When we have CH or CB, we can insert H. Let's see how these insertion rules work. You just need to work out what polymer would result after repeating the pair insertion process a few times. Okay, I start with NNSB and I'm trying. Okay, I have CH. No, I couldn't find it here. HH, I don't have that. I have CB. Does it mean that on this step I will have okay, CB is replaced with C, and I will have NNC. And do I start from the beginning then? Not sure. The first one is the polymer template. This is the starting point. The following section defines a pair of insertion rule. A rule like AB go to C means that when element A and B are immediately adjacent, element C should be inserted between them. Okay, here in this case NNCB means CB will make NNCHB. Okay, interesting. And then now the most important part is, are we on every step we are using all of these rules, or on once we use a rule we simply continue in the following one and so on. This insertion all happens simultaneously, which means on step 1 we are processing all of the rules. We are looking, okay, is that this one or this one and this one, and we are simultaneously having NN going being separate with C, we have CB being separate with C and B, we have this and C and so on. Okay, when we start we can see here we have step 1 and we apply 3 of the rules. On step 2 we apply all of the other rules and so on. And here that's explained. So starting with the polymer template NNCB, the first step simultaneously consider all 3 pairs. The first pair NN match the rule NC, so element C is inserted between the first N and the second N. The second pair matches the rules, so element is inserted between the third pair CB match the rule, so element is inserted between the CN of the rules. Notice that this pair overlap. The second element of one pair is the first element of the next pair, also because all pairs are considered simultaneously and certain elements are not considered. Okay, we do the first rule, insert one element, the second and so on, but we do that at the same time, which means that we couldn't use CN at the given step. We have the final one. Again, that's perfectly fine. Here are the result of your steps. We have like 4 steps. And what's our question? Apply 10 steps in pair, insert to polymer template and find the most and least common element in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the less common element? Okay, here I need to see is B or N the most common element, and after that probably subtract H from it because it and count on that. Okay, that's pretty straightforward. Let's see how GPT-4 will deal with that. It doesn't seem very hard. Okay, we're here. We have our context, our instruction, our input. We're going to GPT. We start a new session. important thing, we're using GPT-4 for this one. We have 25 messages per 3 hours, and let's see what we get. To solve this task, we need to follow the steps. Read input from the file, parse the template, okay, we have the read the file as a separate function. We have the polymer, and we're getting the polymer and the rules as output. That seems very nice. Apply insertion is the rule that we will be calling multiple times. We're reading the file, we're going 10 steps, we're applying the insertion, we're counting the element count, we're getting the max, the min. Very clever. The max is 0, the min it's as much as can it be, which is again 0 if the length is 0. So far the program looks fantastic. It's split it on small functions and so on. I mean, the code from GPT-4 more and more I'm looking, actually it's it's a bit it's actually significantly better than the average developer at that stage. As a code organization, as you can see yourself, it's reading the file, it's handling errors, it's splitting important part of functionality for the insertion as a separate function. It's counting the elements in different function. It's concise, and because we deliberately said that we are competitive programmers, it's not even in the row, and it doesn't bring us meaningless comments and so on. It's in in this stage, yeah, it started looking like not programming with GPT-4 and doing it yourself. Probably will result in in the most case lower quality code, but yeah, still we need to verify certain things, and we need to be careful for parsing the input and so on, because in the previous task also the solution was very good, but was unfortunately ignoring empty line, and we needed simply to fix this kind of errors. But let's look in our case. We have this test input. We always start with our test input. We have our polymer, tac. Here we're expecting for our test input to have 1588, and here we actually have significantly bigger set of rules, and we want to see what will be the difference between the max letter compared to the min one, and we can see that we have 100 rules, which is definitely a lot more than what we have in this part. We can see it going out of index range, and as I mentioned previously, this was happening because here we can see, let me show you, in that place we start with the polymer. I would assume that everything's fine. Yeah, we can see it, but however it's followed by empty line that we don't take in account, and here we simply need to add, okay, now you can have an empty line, we want to skip this line, go further, we still want to use your buffer and scanning line by line. If the file is humongous and so on, this logic is perfectly fine. And let's see if we get the correct rules and everything is parsed correctly. Rules. Up. We are running, we have the rules like a map. We already saw that we have the polymer correctly, and the value 9588 looks legit, and the only thing that we want to do is to change the input. And now we are getting 2000, and that was solution for day 14 part 1, and I hope to see you in the next video. Bye.